What's up, everybody? Welcome to System Covers Live. I'm David Wilson, and we're back again with another Friday stream where we get together as a community and talk about whatever topic I've come up with for the week, and this week is no exception. It should be a fun stream today because I don't know what the hell I'm doing, but we're going to figure it out as we always do. So that's fine. It's great. It's been a nice Friday so far. You know, the weather's finally warming up in Athens again for the second time because it happened before at like the beginning of March or middle of March, and then it got super cold again, and now it's gotten warm. But the downside of that is that it is allergy hell season, so you may hear me sniffing and sneezing and sounding a little bit under the weather, but it's just allergies. You know, there's just a bunch of stuff in the air out here. All the plants, all the nice roses are blooming, flowers are blooming everywhere, which means that I'm basically sneezing and coughing all the time. Left Pad says, isn't that like every stream? Which one? Not knowing what I'm doing? Yes, that is every stream. That's for sure. That's the whole point, though, right? This is just like a journey of discovery for all of us together here. We just come in, we scratch our heads, and we collectively figure out how to do something that should have taken 5 minutes, but it takes 2 hours. And usually we don't really make much progress either. But it's okay. It's just the way. It's the way the System Cupper streams work. I've accepted it. I'm guessing you've accepted it if you're still here after this many years. So thank you for indulging in my desire to just bumble around for 2 hours on Fridays, because it's fun, I think. All right, let me say hello to the people who are here so far. I see Talos, Pegaso, Luis, Fade, Beachal, Dave. Hey, Dave, nice to have you here. Infreak and Left Pad. I also see producer Ashraz in the chat, though he hasn't said anything in the IRC yet. Someone is demanding me to say hello to them, but I don't think I want to. Hello, Trev. Hello, Cal and Glenn. Oh, allergies? Isn't it every stream? Maybe. Glenn says, that's how the way my whole life works. Yes, I mean, that's really the best way for life to work, is that you just figure things out on the fly because you don't really know what kind of situation you're going to be in at any given moment. I mean, you can be super like over prepared for every possible life situation, but I don't know. Is that fun? Maybe it's fun for some people. It's kind of boring for me. Cal says, this one is interesting to me because I just don't get Spritely Goblins. Me either yet. I understand the reasoning behind it, but I haven't actually used the APIs enough to really know how to use them well yet. We're going to figure it out, though. Over on the YouTube side, I see Fabian and Erky. Nice to see both of you there. If you're in the YouTube chat or in the Twitch chat, say hello so I can say hello to you as well. Technomox says, sounds like my experience with Trafic and Docker today. Simple thing that would have taken 15 minutes. I've been fighting with for the last hours. Yeah, it really... some things are just unnecessarily complicated. And other things aren't, but they still end up being complicated to figure out. It's just a matter of how things go. Hello to RZMJ. Hey, Minas Mezar. So, yeah, I'm looking forward to looking into Spritely Goblins in just a moment. What else? Let's see. Tara says, I've just fought a whole day with Docker and Trafic as well. Oh. And now that it's working, I'll never touch it again. Hopefully it's one of those things where you don't have to touch it again. I don't exactly know how that works. The Ugly Dev says, what's cooking today? We're going to experiment with a cool library called Spritely Goblins. Ashraz says to Tara, move it to Podman now. Is it, Podman seems cool. Aside from being able to run rootless containers, I don't really know what the other benefits are. Maybe it's a lot more lightweight, easier to configure or something. I've used it only very briefly. Infreak says use LXC. We're gonna get lots of container suggestions now. Move to a pod, man. Are you suggesting, Trev, that people should just be pod people? Just, you know, live in a tiny, like, what would you say, like 100 square foot apartment? Just living in your bed, eat in your bed, and then take a shower with a bucket. Cal says, web-based mub with Guile and Goblins, waiting for Fade to say something about how Lambda Moo got it all figured out in Common Lisp 30 years ago. Is Lambda Moo in Common Lisp? Tara says, if I had the choice, I would, but sadly, it's not a drop-in for Docker Compose. Yeah. Tara says, you can't drink a mimosa at 11 a.m. in a pod. Summer Emacs, yes. Summer was extremely surprised at the fact that I called her life unreal earlier today. I think she's being modest. I think she has a very strange life. And it's perfectly fine to have a strange, unreal life. But if you're not willing to admit it, then maybe you really deep down know that it's unreal and you just don't really want to acknowledge it. She had a mimosa at 11 a.m. In her defense, it was a vacation day for her. So I don't know. I mean, I'm not going to judge. I mean, I drank a couple beers at lunchtime yesterday, so what can I say? It was also a holiday, so what can I say? Ashra says, that's it, I'm quitting my dev life and go do whatever she does. Yeah, well, she's basically running around the globe doing secret missions, I think, because she's a CIA agent. This is well-known information, by the way. Let's see. Hey, Paul. Nice to see you. All right. Faith says, mimosas are literally designed to be eaten at brunch, which happens by definition before noon. Yes, I guess so. All right. Let me close out some stuff here. Yeah, Fikri. Let's see. Not quite breakfast, not quite lunch, brunch. Yes. Well, you know, you need to have one meal where you can just sort of like pig out a little bit and just use the excuse that it's making up for the fact that you didn't have breakfast or lunch. So you're kind of, you know, solving both meals at once. Okay. So news. Once again, I'm kind of like head in the clouds, don't know what else is happening in the world, so if you have news suggestions, let me know. But I will say again that the Spring Lisp Game Jam starts next week. It's next Friday, a week from today, May 9th, and it goes on for 10 days. It's a fun little event where all kinds of freaky Lisp people get together and work on a game of their choosing with a Lisp of their choosing, even one that they wrote themselves, whatever you want. The whole point is just to try to make a game within the span of the 10 days that are given to you. You can work on a game that you've already started or work on one from scratch. I think that you have to have it be open source code at least. It doesn't have to be free software. It could be just plain open source. If you want to make your, if you want to continue working on a game that you already have. But usually it's more fun to just start something from scratch, just to use your creativity and see what you can accomplish within 10 days, especially if you're using a new language or a set of tools in that language, like a library or something. So it's good fun. A lot of people in the community have done it over the last couple of years. We've, you know, have a good time talking about it on IRC and the Fediverse while we're doing it. I will be participating. I will be streaming some of my work next week during the Crafter Hour stream. So the following week, because next week it starts on Friday. I haven't decided yet whether I'll try to stream Crafter Hours on Friday morning. I might. Let's see. It starts at May 9th at 7 a.m. I don't know. Is it my 7 a.m.? Okay, it's 4 UTC. Okay. So that works for me. I could actually stream Friday morning if I wanted to. So I could potentially do a Crafter Hour stream on Friday to kick off a project, then stream again on Monday, Wednesday, and maybe the following Friday to try to see if we can finish something in time for the thing to be finished. I think that also May 19th, what day is that? Is that Monday? Calendar. 19th is Monday. It ends at what time on Monday? At 7 a.m. the same time. So, yeah, I wouldn't be able to stream on Monday. So basically, would have maybe a chance for 4 streams to make some progress on that, if I do it the way that I'm thinking about doing it. And today's stream will kind of be an experiment just to see whether I want to try to use goblins for my game in this stream. We'll talk a bit more about that in a second. All right. Infreak says game programming in Common Lisp or Scheme. I mean, you could do either. Plenty of people do it in either. Common Lisp has a lot of libraries. In Scheme, there's good stuff by Dave Thompson, like Chickadee, or is it Catbird? What is the next one, Dave? I don't know if that one's like well documented enough yet for people to want to try using that, but definitely Chickadee is a wrapper on SDL, and it's great for making desktop games. You could also try to make a game using Guile Hoot in the browser using browser APIs. I did that the last time with Lambda Dungeon. Maybe even the time before that. I think I did the Cybersol, the solitaire game that I worked on. I did that with Guile Hoot in the browser as well. So it's definitely possible to use Guile Hoot to do a browser game. I kind of like, I think browser games are best for game jams because people can get to them so easily. If you have to like package up your game as a desktop application and deliver it to people and make it work across multiple OSs, it's always a pain in the ass. So in my opinion, it's better to do a browser-based game if you can, whether it's a game that runs purely client-side in the browser or if it has like a server component or something. It's just easier that way. So Dave says, Catbird is an unreleased experiment. Do not use. So yeah, that's my recommendation is definitely try to find a way to make a game in the browser if you can. I'll talk more about what I have in my mind this time. Let's see. Roberto says, I would like to use Guile and Hoot for the game jam, but I need to configure Emacs properly and ready for it. And Ashraz says, maybe you want to show that today too. Not for Hoot today, probably, but later. All right. Yes, Dave has a template in the chat, on the IRC chat. Actually, let me just go to that on the screen so you can see it if you haven't seen that. So codeberg.org/spritely/Hoot Game Jam template. Is the Spritely stuff moving to Codeberg? Because, to be honest, I kind of hate GitLab, so being on Codeberg would be way better. Let me star that, actually. And watch it. It's clickable on YouTube chat. Thank you, Ashraz. All right, so that's a good starting point if you want to use Guile Hoot as a platform for developing your game for the game jam. Dave says all the Spritely stuff is on Codeberg now. That's awesome. So, what else? Yeah, so that's starting on May the 9th. Definitely recommend joining that. I see that the numbers of people who have joined are increasing because it was like 30 something the last time I looked at it, so 41 is good. Dave says if all goes well, there will be a Hoot, excuse me, a Hoot patch released before the jam starts. That's cool. And relevant updates to the template. Nice. So, all right. So today what I want to try to do is get a little bit more familiar with Spritely Goblins. If you have not heard of Spritely Goblins, well, we've talked about it a few times on the channel. It is a distributed object programming environment, or basically it's a library for Guile Scheme that provides you with a way to write distributed programs using a mixture of like the actor model, which is kind of like a way to have message passing between independent lines of execution, either locally or maybe on another server, which doesn't really happen in all cases with the actor model, but at least in the case of Spritely Goblins, it does. It tends to enable you to write more functional style code and keep your state mutations localized to a single process, and then have everything just be like messages that get passed between the different processes of execution, the different actors that are in the system. So it's an interesting model of writing applications. And the other aspect of Spritely is that it uses something called OCAPN, Object Capability Security Protocol. I'm not getting that perfectly right, but basically the idea is that there's a specific protocol underlying that which makes it secure, or at least more secure than typical interactions between independent things on a distributed application network or something would normally be. So it's an interesting model. I have not fully wrapped my head around it. I've looked at it a few times. I've seen some of the demonstrations, some of the presentations like this one here at FOSDEM. There's a lot of different information on it out there, a lot of things written up about it. A lot more people are starting to use it now. I've seen some pretty interesting things. Definitely they're working on porting GNU Shepherd to actually use Goblins underneath, which brings some pretty interesting possibilities for the future about how Geeks could work. Because if you have, multiple Geeks machines that are all have their shepherd, so their init process shepherd, their root shepherd, communicating with each other, then you could potentially distribute load over machines or distribute services across machines, do a lot of really interesting things that isn't really possible right now, and do it in a secure way as well. So I'm kind of butchering the explanation, but we will see more about that as we get into trying to explain this. Dave sends a link of ocapn.org, which maybe gives some more explanation about how all this works. So it's really interesting stuff, but yeah, I still haven't got my head around it yet. And the goal of trying to experiment with this today is that I have an idea for the Game Jam to work on a web-based MUD or MUD-style game. If you don't know what a MUD is, it's a multi-user dungeon. So back in the dark ages of the 80s and 90s internet, there used to be there's the initial internet that was in the 90s, but there's also like BBSs and whatnot in the 80s, where people would connect to games that were all text-based, and they were multiplayer games where you usually telling that into a server or connect it via a BBS. You type in text commands to the game, and then things happen in the game. They sort of write output back out to you. So it's almost like a command line program that's a game, but it's a networked game where you're there with other people and you can interact with other people in the game world and do things together, whatever you want to do. So it's a really interesting style of game. I've been kind of obsessed with MUDs as a type of game project that's really good for learning new languages or libraries or platforms over the years. And I think it's an interesting way to experiment with Guile, with some of the stuff we've been doing lately on Craft Hour streams, where we've written server-driven web applications using Datastar. So I'm not using anything on the client side of the browser except for just the Datastar library with some specifically annotated HTML that I'm generating on the Guile side using SXML. And then the Datastar library facilitates a lot of dynamic interaction between the client and the server, and pretty much all the UI is just coming from the server being generated in real time. So what I'm thinking is I want to do something similar for a web-based MUD, where the website is the interface that you play the game on, and then all the actual logic for the game is happening in Guile. So if everything's happening on the server in Guile, what that means is we have the ability to potentially use Goblins as kind of like the way to model the operation of the game inside. The game engine would be written using Goblins. Now that's kind of like using only half of the benefit of Goblins. Obviously, if I were to use Goblins in the client as well, which I'm not sure, I think we heard that Goblins works in the browser now with Hoot. Dave can correct me on that, but the idea is that eventually Hoot would be able to use Goblins and communicate to Goblins running in Guile. I'm not going that far yet. What I'm just going to do is try to use Datastar and server-side Guile to do the full sort of client-server aspect of it, and then internally maybe use Goblins for that. Now, I don't know if that's the right thing to do. Part of what we're trying to do today is evaluate whether Goblins is a good fit for this process. But either way, we're going to learn something about Goblins, I think, because we're going to try to actually use it for something, right? So that's the goal for the day. What we do today probably won't really be used verbatim in the game jam, even if we do make some progress with it. I'll probably just start from scratch after I think about it a little bit. Dave says a subset of Goblins does work in Hoot now. We have real programs running this way. That's awesome. Is there any like example programs on the internet, something that's like non-trivial that people could look at? All right. So let's check out the main page. Osloy says, as opposed to before when only the fake programs would run this way. Yes, that's right. Only the imaginary programs would run that way. So at the heart of Spritely is Goblins. It's distributed object programming environment. Goblins provides an intuitive security model, automatic local transactions for locally synchronous operations, and an easy-to-use and efficient asynchronous programming interface for encapsulated objects which can live anywhere on the network. Its network programming model abstracts away these details so the programmer can focus on object programming rather than protocol architecture. The other thing is that it does give you the ability to do something called time travel debugging, which means that you could basically go back and forth in time for the state of a given object in the system, because there are transactional updates where basically at every point in time, I think the state of the object's being captured. So you could roll it back basically and try things again if you want to. I don't know exactly if that would be useful to us in the purpose of what we're doing, but I don't know, it's there as an option. We could potentially play with it if we want to, but we'll just have to check it out. Dave's giving some links in the chat. Let me see. So I'm going to go to the news page. I'm going to try to capture some of these in the show notes. We got the Spritely Goblins thing here about working in Hoot. Excuse me. All right. And then there's source of Goblin chat. files.spritely.institute/embeds/goblin chat light/goblin chat. Thank you. Okay, it's an adaptation, chat light.scm. There it is. Okay. So people want to check out using goblins with Guile Hoot. All right, there you go. All right. So let's get into the documentation, shall we? Thank you, Ashras, for replicating the links. Appreciate it. So let's see. Read about Goblins design. I highly recommend if you want to learn more about sort of the model of Goblins and the sort of underlying object capability protocol stuff. Read the Heart of Spritely document. I've tried to read this a few times and I understood what it was telling me, but then I seem to forget the information I've read here. So I should probably read it again, but we're not going to read this right now because it's not really going to be useful to us. I think I'd rather just go and try to learn how to use Goblins through the documentation, okay? So we'll get started by doing that. So we're going to look at the Spritely Goblins manual. Ashra says, but reading documentation is bliss. I agree. I also like reading documentation. I think that if you're here, you probably are the type of person who enjoys reading documentation, because how would you be able to survive otherwise? This is kind of a documentation-heavy avocation. Is avocation the right word? Dictionary avocation. Subordinate occupation pursued in addition to one's vocation, especially for enjoyment. Yes. So this avocation requires enjoying reading documentation. ASMR documentation reading session wins, says Ashraz. I guess it's going to be today because we're going to have to read some documentation. This is the manual for Spritely Goblins, a distributed object programming environment. That's terrible. I have to do more of a vocal fry. This is the manual for Spritely Goblins. Sorry, folks. I know. It's awful. All right, so what is Goblins? Okay, that's a lot of things. I'm glad somebody found that funny. All right. Quasi-functional object system. Users hold on to references of objects actors, but objects actors are just procedures. Rather than directly mutating, objects actors can specify that they should become a new version of themselves when they handle the next invocation. Okay. All right, let me see. Can I try to distill this? Fully distributed, networked, and secure P2P communication via OCAP-in, the Object Capability Network. Communicate with other objects over a network connection. Distributed object interactions are safe because of security guarantees. Let's see. Transactional updates. Changes happen within a transaction. Sounds like that only happens locally, though, not across network operations. If an unhandled exception occurs, goblins can roll back history as if the message never happened. Wouldn't you love it if you make a mistake in your life and you can just sort of roll back time and then forget that it ever happened and then just go forward again as if you didn't even know it happened? Well, apparently Goblins gives you the ability to do that, or at least it gives your code the ability to do that. You'll probably remember that you made a mistake. All right. Left Pat says, I would probably love it, but I never make mistakes. Yeah, there's 2 A's there, Left Pad. I'm sure that was probably on purpose, though. All right. Who makes mistakes? Not me. But I've live streamed myself coding enough times that, yeah, there's plenty of mistakes. All right. Time travel. You can snapshot old revisions of the system and interact with them. Okay. Where are we, says Left Pad. Asynchronous programming with sophisticated promise chaining. Message passing with promises is supported. Promises work such that there's no need to wait for promises to resolve before interacting. You can communicate with the future that doesn't even exist yet. Sent a message to that remote car factory asking for a new car. Why wait for the car to be delivered? You can send it a drive message at the same time, and both messages can be delivered across the network in a single hop. So it sounds like you've got mailboxes on either end, and you can just sort of just fire and forget the things you need it to do, and then it will just do it later, I'm guessing. Glenn says, isn't this how we learn? Yes, mistakes are how we learn because nobody can get things perfectly the first time, except for me, obviously. So communicating event loops, objects across multiple event loops, aka Vats, can communicate whether in the same OS process or across the network. Now, see, there's the thing. I don't really understand Vats yet. When you describe it like this, multiple event loops, it sounds like you might want multiple event loops like in different OS threads or separate processes or something. Because usually the value of an event loop is it allows you to serialize concurrent operations. Does that make sense? Basically, there are things happening that are sort of being threaded together, but they are being executed serially because you're trying to avoid the complexity of parallelism. But then maybe you want there to be a separate event loop on another thread so that you can offload work to the other thread but still use the same programming model. So I'm guessing that's where Vats kind of come into play, as you want this behavior. But I don't know. So we'll have to take a look at that. Synchronous and asynchronous behavior integrated but distinguished. Both synchronous and asynchronous programming is supported, but only objects in the same vat or /event loop can perform synchronous immediate calls. All objects can perform asynchronous calls against each other. So the difference between synchronous and asynchronous programming is that with synchronous calls, you're calling a function, and the code that calls the function is waiting for the function to complete. It's blocked before the function that it calls returns. So if you call a function that then goes and then like spins in a loop indefinitely, then your whole program gets hung or hanged. The asynchronous side of things is basically you can call something and then it will go off and do something, and then you will just be sort of waiting but asleep in a way until you get woken back up again. Or it could just be that you call something and then you get an object back that's like a promise that says, you could check this to see when things are completed, then you just kind of go on with your life. So basically, it gives you a way to start some kind of behavior separate from your own line of execution and either wait on it to finish or continue on with your life and do whatever you want. Dave says a vat is a message queue and it processes them one at a time in a loop. Each goblin actor lives in a vat. Yeah, I'm kind of wondering how that works in the case of a game like the one I'm talking about. Like, I wonder if all of the game objects need to be in the same vat, or if there's a reason why you'd want to split them into different vats, but that's something we'll have to talk about. Ashra says maybe use a kind of sketching program to show a rough flowchart or some other kind of visualization. Yeah, that would be a nice thing to do. I don't have that. I'm not the Primeagen or Pirate software, so I use GNU Geeks. I don't have these fancy tools. Sure, yes, I know. I could open the GIMP right now. I'm just a little bit lazy. I'm sorry. A library, not a language. Goblins itself is a library that can be utilized across a wide variety of Guile programs. Install rnote. Is that a thing in Geeks? rnote. No. There's a diagram on the docs. Thank you, InFreak. Okay. Anyway. Goblins itself is built for object capability security, which is to say that you can only operate on the references you have access to. I'm getting a frown. I'm getting a frown here. Goblins embraces and builds upon this foundation. However, the full OCAP security will require utilizing the sandboxing features of Guile. Demonstrations of this are coming soon. rnote is available in a Flatpak. I have no idea about the Geeks ecosystem. Yeah, well then, in that case, I could probably use it, but who wants to go install things from Flatpak right now? All right, getting started. Installing Goblins. You just need to install Guile Goblins in Geeks, which I've got a manifest file set up already for this. Set up for hacking on Goblins. Now, there's some suggestions here. Use Emacs. Use Geyser in Emacs. Turn on show paren mode so that you can edit programs with parentheses. I'm guessing if you're using Lisp languages already, you know this. And isn't show parens mode like already on by default in a lot of cases? I don't know that I've seen it not be on by default, so whatever. You probably also want some combination of smart parens or paredit, rainbow delimiters, and highlight parentheses, which, yeah, definitely, I don't use smart parens or paredit right now. I probably should get back into paredit at some point. Rainbow delimiters is pretty useful. I'm using, in this configuration, I think the one that I stole from Emacs Solo by Leonix, which I think I saw Leonix before, but he's not around right now. No, it's actually not turned on. Emacs Solo, no. It's not in here. Yeah, it was enabled for me by default too, I think. Okay. So that's a pretty, straightforward setup. There's also a note about a live hacking fix. Apparently, the way that Geyser works doesn't really gel very well with how Goblins works. So there's a simple fix to this. When you start a REPL, you need to load up the Goblins module. I'm guessing it must throw some hooks in there to defeat this problem so that you can do live coding with Goblins inside of Geyser, which we'll try to do because I do want to do some live coding today, some REPL-based coding. Next, a high-level view of Goblins. Let's sketch a network of Goblins objects wired to communicate with each other. So we have node 1 and node 2. I'm guessing these are either separate processes or different things on the network. Running separately from each other but connected to each other over the network via OCAP-N and CAP-TP. Vat A and Vat B are separate event loops which live on node 1. Vat C is an event loop which lives on node 2. The individual objects live in Vats, aka event loops, which contain objects. Alice and Alfred live in Vat 1. These are objects. Bob lives in Vat B. Carol and Carlos live in Vat C. All right. The arrows between the objects represent references these objects have to each other, so they don't all reference each other. There's sort of a relationship with certain objects, but they don't see each other, necessarily all of them. Two objects which are in the same vat are considered near each other. Not in the same vat are considered far. Any objects can invoke each other by asynchronous message passing, assuming they have a reference to each other. So an object cannot call another object unless it has a reference to it. Hey, Alex. All right, let's see. Each vat has an actor map and underlying transactional heap used for object communication. This is what permits transactionality and time travel. Actor maps can also be used independently of vats for certain categories of applications. This sounds like a persistent data structure. basically like a hash tree or something to make it possible to have a versioned state contained inside of the object. I'm guessing that's what it is based on the way it's described. I don't really know. Another way to think about this is the following abstraction nesting dolls. You have a node that has a vat inside, which has an actor map inside, and or at least probably many of these. They're objects. Actor maps, transactional heaps, which contain a mapping of references to object behavior. That's probably methods, I'm guessing. All right, the VAT model of computation. We're going to try to run through this real fast. I don't want to spend too much time reading the docs to you. VAT model of computation. A VAT is an event loop that manages a set of objects which are near each other. Bot operator slightly inebriated. Ashraz. That's okay, man. I would be too if I didn't have to talk for 2 hours. An event loop is simply a loop which wait on a queue of events. In the VAT case, a queue of messages is sent to objects within the VAT. So an event loop, in this case, a VAT has an event loop, which is actually it has a message queue that is managing everything that's going to the objects inside of that VAT. So there's one message queue for the event loop, which is how an event loop works. You have a queue of tasks to be dealt with in the event loop. It basically goes from one task to the next. And then as code gets executed, the code that executes will add more tasks to the queue to be executed later. So you effectively have an endless queue of things to do, one after the other, until the program finishes. And then everything inside of that single VAT, there's multiple objects in there. They're all kind of executing concurrently inside of the single event loop, right? You have a queue of events to be dealt with. Yes. All right. So objects which are near can perform synchronous call return invocations in a manner familiar to most sequential programming languages. Aside from being a somewhat more convenient way to program, sequential invocation is a desirable because of cheap transactionality, which will be expanded more upon more later. Goblins uses the $ operator to perform synchronous operations. I have a suspicion that what you will often end up doing is have an object that's receiving messages asynchronously from the outside and then invoking things internally to the VAT synchronously so that you can make use of the transactionality that it provides. But that's just my guess. Let's see. Both near and far objects are able to invoke each other asynchronously using asynchronous message passing, same as the classic actor model. And let's see, it does not generally matter whether or not a far object is running within the same OS process or machine or one somewhere else on the network for most programming tasks. So basically, you would probably end up doing asynchronous tasks, asynchronous message passing most of the time, except for whenever you want to leverage the synchronous stuff for transactionality, which we'll have to take a look at and see where it's more appropriate to do either of the two. Let's see. Goblins uses the back arrow operator to perform asynchronous operations, but for both programmer convenience and for network efficiency, Goblins supports promise pipelining. Messages can be sent to promises which have not yet resolved and will be forwarded to the target once a promise resolves. Sender of the message is handed back a promise to which it can supply callbacks, listening for the promise to be fulfilled with a value or broken. So if you've used languages like JavaScript before, which actually has promises as a kind of core thing that you come in contact with. A promise is an object that you get back, which usually has like a couple of events that you subscribe to. One is like on success and one is on failure or error. And it just basically allows you to attach a callback or a series of callbacks that get invoked whenever whoever received that promise to then complete the task or to actually execute the task that promise is associated with Whenever they complete it or whenever they signal that there was an error, all the callbacks get called. So it's a way for sort of asynchronous handling of a long-running task, I suppose. And it sounds like Goblins provide something similar. So let's see. Okay, and as usual in the VAT model of computation, individual messages sends to a VAT are queued and then handled one turn at a time, akin to the way board game players take turns around a table, which is indeed the basis of the term turn. Message addressing the message which addresses a single object is passed to the recipient object's current behavior. Now that's something that I'm not 100% clear on yet. This object may then invoke other near objects. Okay, that makes sense. Residing within the same VAT, which may themselves invoke other near objects in a synchronous and sequential call return style. Any of these invoked objects may also change their state/behavior. Behavior changes appear purely functional in Goblins. Spawn new objects, invoke ordinary expressions from the host language, or send asynchronous messages to other objects. All right, let me try to unpack that for a second. A message which addresses a specific object is passed to the recipient object's current behavior. So an object has a current behavior, which makes it sound like it could be in different states at different times. This object may then invoke other near objects, which may themselves invoke other near objects. And any of those objects may also change their state/behavior, or spawn new objects, or invoke ordinary expressions, okay? So there's a few different things that can happen. Cool. Cooperative multitasking within VATs. All right, so we got some example code here, which is great. An individual VAT is not parallel. Only one object within a VAT can be working at any given time. Makes sense. However, VATs can work with one another cooperatively to multitask. This is done by asynchronous. Okay, we got another typo. This is done by asynchronously passing messages to objects on other VATs, possibly waiting for the reply and then continuing work. VATs can work with one another cooperatively to multitask. Okay, so basically saying you have multiple VATs that are running on distinct threads or some other way to split the work. Maybe separate processes, maybe separate systems, etc. In this way, it's important to not block a VAT, as that will block the event loop and prevent the VAT doing work. Instead, we should be using Goblin's promise system in places where we would block. So Dave says, you can think of an actor reference as a pointer to its current behavior, like a get branch points to the current head commit. That's interesting. Interesting way to describe it. Let's take the following example, which has two actors. Sleeper, which sleeps for 10 seconds and then returns awake, and hello, which just returns the symbol hello. Both actors are spawned within the same VAT. We will then use another VAT to invoke both of them at the same time asynchronously. All right. So we got fibers also, which is interesting. Where is fibers being used? Sleep 10, probably. That must be where fibers is coming in here. So I'm guessing that Goblins is sort of using fibers under the covers. That way things like sleep just sort of work. So we got define actor, sleeper, and BCOM. I don't know what BCOM is yet. Maybe Dave can give us a hint on the lingo there. There also seems to be a special syntax for actor names. This caret here at the beginning is not really special other than just it's like a naming convention for an actor. So the actor itself has a lambda, which takes no parameters and just sleeps for 10 seconds and then returns awake. There's another actor called hello, which literally just returns hello whenever it's called. Now we spawn a VAT. Dave says Goblins is built on fibers. Cool. Spawn a VAT. We define a sleeper, which is an instance of the actor sleeper inside of the context of a VAT. So with that a VAT, we spawn the sleeper. I see. So Dave says BCOM is shorthand for become, one of the fundamental actor operators. Okay, that does make sense. Same thing with hello. We've got with Vat. In fact, how about we just copy and paste this code and give it a shot? Because I already have the code, the project set up. Let me go get the manifesto, okay? I'm going to put Guile fibers in here too. Excuse me. And now I'm going to run compile geeks shell -m manifest.scm Guile main.scm. Let's see what happens. May take a second because I've done this yet. Okay, so I think it's waiting. Oh, compilation finished. Give me 1 second. Overrides core binding spawn. Did I miss something? Ah. No, that's not what happens. So definitely spawn and sleep are being overridden, which means that they are, yeah, it's just like returning immediately. I wonder why that's the case. Do I need, Geeks Gel, do I need a Guile next for this to work? Nothing's complaining. So we got Vats being started up. That should work with fibers. Do I need to do something else with fibers too to get it to like run on the main thread? All right. Let's also check out, just in case, you don't need Guile next. Okay. The example assumes you're in a rep. Oh, do I need to actually invoke something? Well, we could try that. Let's see. How should I do this? One-on-one support session. I don't want to take up Dave's time with that. All right, I need to block the program. We've already got wait and make condition as the last line. Thank you, Dave. And fibers conditions. Let's give that a shot. Thank you, Dave. Let's see what happens when I do this time. All right, so it does seem to be waiting. Let's see what happens. I probably should change that to like a 3-second sleep or something so we don't have to wait for 10 seconds. Let's do 3 seconds, huh? That should be 3 seconds. Okay, cool. So it says sleeper said awake and hello said hello. Let me turn on keycast tab bar mode also. Quick hack. Yeah, that's good. I mean, that's good enough for now. If they can operate independently, then that's good enough for me. So, sleeper said awake, hello said hello. Let me actually just try to digest what's happening here. So we've created 2 actors, sleeper and hello. They have just simple functions as what their behavior is. We've created 2 vats, one called A vat and one called B vat, responding to vats. Nice thing is you don't really have to think about how these are going to run in parallel. They just sort of set themselves up to do that. That's cool. We have sleeper and hello, which are the spawning instances of these actors within the particular vats. Same thing for B vat. We have with vat, B vat. Now we have on and arrow for sleeper. Sounds like this must be listening for a message from sleeper. Let me see if I digest this. So this is basically executing code. So I'm guessing with that is a block where it's a block. Let's say it executes the code as a block. Whatever comes after is any number of expressions being executed within the context of a vat. So inside of bvat, we are waiting for a message from sleeper, And then where you have a lambda to deal with handling the response. I'm guessing this on probably has another lambda you can give for dealing with errors as well. So on sleeper, message coming in from sleeper, we do basically a pretty print saying sleeper said response. In this case, sleeper said awake. And then on hello, lambda response, pk hello said response, which is hello said hello. All right, so we're sending two messages. We're not sending two messages. We are waiting for things to happen from both of them. But I guess we're sort of invoking both of these in a way. I'm guessing that because these lambdas don't take any parameters, this on is actually sending a message, just sort of like pinging that actor and then waiting for a response back, right? I'm pretty sure that's what's happening here. And the documentation said that arrow is how you send an asynchronous message. So you would be able to do whatever number of parameters on this as the lambda itself would take. I'm guessing. I don't know, but we're going to find out. Probably Dave will be able to tell me. But that seems to be what's happening here. We are sending a message to sleeper. We're waiting for the response back with a callback. Dave says, with that is the way that you bootstrap work inside of that from the outside. Yeah, so basically you can sort of step into a vat and execute something, maybe to start off a process inside of the vat so that it continues running, which makes sense. You would need that. All right. So then the documentation continues. During those initial 10 seconds, the entire AVAT is blocked because of the sleep 10 call. Dave says, yes, you can send an arbitrary number of args with both the arrow and $sign, as those arguments are passed to the actor's behavior. Okay, so that's cool. That makes sense. So during those initial 10 seconds, the entire AVAT is blocked because of the sleep 10 call. And that's because sleep 10 is blocking the fiber that the vat is running on, because a fiber is also that's where the event loop is coming from. It's coming from fibers, in my understanding here. So whenever you sleep, what you're saying is halt the operation of this particular event loop or this line of execution until this thing happens, and then resume. So whenever you call sleeper, you are causing the AVAT to wait for 10 seconds before it does anything else. Otherwise, both these messages may have just executed, not necessarily in parallel, but one after the other right then, without waiting. Instead, we should rely on promises. The following code fixes the blocking issue. So now sleeper does something different. So define sleep vow. It vows that it's going to sleep. Spawn fibrous vow. We're getting into some real fantastical language here. Sounds pretty cool. So define sleep vow. Spawn fibrous vow. Lambda with no parameters. Sleep 10, return true. On sleep vow. So it seems like you can use vow with a promise, and then you can just do something with the response. So what we're doing here, okay, I see this. We're basically separating the sleep part of the operation from the return of value part of the operation. And that's kind of interesting. Now, I can't tell from the, okay, we're saying on sleep vow, we're making that a promise. Spawn fibrous vow. I don't know what the difference is between this and making a promise from on. I wonder if on is sort of doing that under the covers. Define actor. This is still the same for hello. And is the rest of the code the same? It appears to be the same. Okay. So let's copy the newer version of Sleeper here. Right there. We're just going to drop that straight in. I'm also going to make sure to reduce that delay because I really don't want to wait 10 seconds. And then I'm going to restart the compilation. So hello said hello. So we already saw that. Wait, now we got an error here. Unbound variable spawn fibers val. What did I miss? Goblins vat. Okay, so I missed a import. Goblins vat. All right, let's start it again. All right, so hello said hello. That's returning immediately. and then sleep reset awake comes back later. So because this process of sleeping and then waking up and returning something has now been split into two, it gives a window of time where the hello actor can receive its message and then immediately return something before that sleep is done, and then the awake gets returned. So you're basically making an individual actor more concurrent by not blocking its own code from completing whenever other things need to be happening concurrently in the same vat. Now, we kind of still need to understand like the right places to use these things like spawn, fibers, vow, and whatnot, but it does seem like that's the way that you add something new to the event queue. So this fibers vow is not actually doing anything yet, I'm guessing, until on is called. So it calls on, and then it invokes this vow. And then once the vow is complete, then it runs whatever the function is that's after that for the result. And then in this case, it just returns awake. But it turns this into a promise. So now the sleeper immediately returns a promise whenever the message is sent. So probably just waits until it's done and then eventually comes back and handles the result later. Does that make sense so far? Everybody with me? If you haven't done much event-driven programming before or event loop-driven programming before, it might not make a whole lot of sense. Dave says, Vats are a cooperative multitasking environment. By doing the sleep in a new fiber, we don't block the fiber that's running the event loop. Yeah, so that's another little aspect here is that since it's using fibers, you can leverage the ability of fibers. You kind of have to understand that fibers is also working there, I guess. Dave says, this is a bit in the weeds for your first program, but we added this documentation because it's one of the most frequent sources of confusion for new users. Well, no, I think it's useful, at least for me as a person who understands this kind of thing, to sort of see how it works. I have a much clearer understanding of what's happening now than I did before, for sure. All right, the initial response from hello occurs immediately when we run the code. Then 10 seconds later, we see sleeper's response. It's because the vat is not blocked, and we're calling spawn fibers val. Vats are built on top of the fibers concurrency library. This procedure calls a thunk, a procedure of 0 arguments, in a new fiber. Okay, so spawn fibers val calls a lambda in a new fiber. By spawning a new fiber, the Vats event loop fiber is not suspended. When sleep is called, spawn fibers val returns a promise that will eventually resolve with the value returned by the thunk. Sleep example can be made even easier by using Goblin's built-in timeout procedure provided by the timers module. Let's take a look at that. Other tasks likely to block, e.g. reading or writing from ports or working with other blocking resources, can be written with the IO module, which wraps the resource in a Goblin's actor that ensures the vat is never blocked. So that's cool. We've got some replacements for common things like timers or IO that will do the right thing whenever you need to use them, so it won't block the event loop. So that's going to be pretty useful. It's also kind of useful in the context of a game, because oftentimes you will want an object in a game to do something on an interval, like wander around in the world or something, and you need an easy way to do that without having to sort of keep track of all the things that need to be done on every update tick of the engine. So something like a timeout running inside of a given object behavior could allow you to do that without thinking too much about it. It could make it really easy to write more complex behavior. But then again, there's less central control over when things happen. So it could be a problem in its own way. All right, so what's next? Let's go up again. Hey, Case. I see Case has ominously received operator status. He's flopping into the chat. Don't ban me, bro. A simple greeter. What are we doing on time? Okay, we're doing good. So, first import goblins. I guess I could have been doing this in the REPL to begin with. So let's just, well, no, I need geeks. That's sort of the problem here. I need geeks to pull in the dependencies so I can use the REPL correctly. Let's see. Actually, hey, Big Edie. Wonder if I could do this. If instead, when I run compile, I use listen. No, it just still doesn't work. All right, fine. All right, so listen is on. What if I go and geyser connect localhost? Do I need to tell it the port? Or is it blocked? 37146. Hello. Whoa. What just happened? Whatever. Eat. Guile, help. Help! Listen equals port. Yeah, default local port 37146 is used. I don't think I have anything else running. Maybe the process is blocked. That's the reason why it did that. Okay. So, just trying to get it into the REPL so we can, excuse me, check some things out. Can I instead Guile REPL? REPL servers. Come on. Are you really going to take that long? There we go. System REPL server. Run server, spawn server. In the current thread where spawn server spawns it in a new thread, I wonder if I can do that in the current thread. So I know this is terrible, but whatever. System REPL server. Let's just see if this works. I could be wrong about this. Hold on a second. Now, if I go back and run it without listen. All right. Let me try to connect this time. There we go. Now we got a REPL into the process. Okay, let me see. Can I run this again with bvat on sleeper response? If I run it again, is it because those have already been executed? Should I just like re-evaluate the vat? That's fine. I don't care. And then I'm going to run this again. Oh, I should probably be looking at the console. Yeah, it is actually happening again. There we go. Look at that. So we're interactively working on these. Yeah. Okay. So with the vat, I'm checking the. I'm sending messages to sleeper and hello. So this actually is working in the REPL, which is great. Confirmed. So, excuse me. Responding to Vats, we create a greeter. Now it's interesting that it doesn't use define actor. It's using plain old define. Why? I wonder. Oh, yeah. I wonder why. What's the difference? Does it explain that somewhere? Either way, I'm very sorry. We define a greeter with, sorry, allergies, like I said, with a bcom parameter. So there's a couple differences I noticed. Define actor, you have underscore in front of bcom. I don't know if there's any significance to that other than maybe bcom is not being used. That's why the name is being done there. Here we see that bcom does not have an underscore, and we have our name, which looks like it's possibly a parameter to the actor. Like when you initialize the actor, it has its own parameter. Yes, because we have here spawn greeter Alice. All right, so that makes sense. So let's think about this in context of a game that we would probably be writing. Maybe there is a game object of some sort, a character that's running in the game, and you need to have their state that you pass in, or at least their initial state. Lambda your name format. And it looks like what this thing does is it just receives a message that has the name that it's greeting as a parameter, and then it immediately just returns a string that greets that person using the name of the greeter and the name of the person being greeted, okay? So we're defining greeter by spawning a greeter with the name of Alice. And then, I see, okay, so we're synchronously calling then that actor in the REPL with a $, sending it the message, or sorry, the parameter Alfred as the first parameter that expects, and then it returns a string back saying, hello, Alfred, my name is Alice. And there's a Goblins REPL here, which is interesting. Oh, we're entering the vat. So you define the vat, and then you enter the vat. So that's kind of cool. Apparently, in the REPL, there's a command, a special command that gets added that allows you to enter a vat, and then all things that you evaluate from that point forward in the REPL are with respect to that vat. That would enable you to do more interactive development. So, for example, if I were to go into the REPL and type enter, yeah, I need to use Goblins first. Enter vat, B vat, entering vat 3. Okay, so I've reevaluated the vat a couple times. That's the reason why it's called 3 now. So now if I were to go and evaluate this expression, the hello expression, let's say, no current syscaller. What does that mean? Let me go into the compilation window. So it doesn't actually say, whoops, no current syscaller. Is that because I'm doing it asynchronously? Let me send a synchronous message to hello. Let's see what happens when I do that. So, $, hello. That's it, right? No current syscaller. I don't know what I did wrong to make it do that. Oh, was I out of the REPL? Is that why? Here we are. Let's try that again. Not callable, not in the same vat. Oh, I went into B vat. Okay, there we go. Evaling in the buffer does not use the context that is in your REPL buffer. Thank you, Dave. So that's only a thing that would be useful if you were in the typing commands in the REPL. Okay, we're learning something new. So if I need to actually enter vat, a vat, then I can call hello, and it will give me hello back. Is that right? Yeah, it returns hello. Same thing for sleeper. It should wait for 3 seconds. It returns a promise. We see that it returned a promise. And then eventually it will come back. Oh, did it not do that right? Let me see if I run it again. If I get a similar error. No. But it might have done something weird. Hello to random code. All right. Anyway, that's that. And then there's a call with a vat. But I guess that's been changed. Maybe the documentation isn't quite up to date with some of the coding patterns that are here, because with vat seems to be the new, with vat seems to be the way to do it now, or at least in the example that we looked at. All right, so very few operations in Goblins spend time operating on VATs directly. Typically, commands like the above only happen when bootstrapping the initial set of actors within a VAT or when hacking. After which the actors within the VATs do their own thing, because they're in an event loop and they're probably continuously doing other stuff. So here's a simple cell which stores a value. The cell will have two methods. Get receives the current value, and set replaces the current value with a new value. So here we have a case lambda, which is basically a way to define a function that has different arities or different numbers of parameters based on how you call it. So if you call it with no parameters, then it returns the value. But if you call it with a single parameter, in this case, it will set the value. So the bcom is it calling it as a function? Bcom is being called as a function. And then the result of wait a second. So it's calling itself bcom new value. I'm not certain about that. Cell bcom new value. It's invoking itself with the new value. And then passing that to bcom. Maybe it will explain it, because I'm not really getting that right now. And bcom, sure, yes, we understand bcom as a concept. But I guess bcom is sort of the indication that this object now becomes whatever is next. Cells hold values, so do treasure chests. Make a treasure chest flavored cell. Taking things out and putting them back is easy. So we're defining a cell that has something inside of it already called sword. If you look at what's in the chest, you'll see it has a sword. If you say that now that there's gold in the chest and then ask it for the value that's inside of it, it says gold. Now you can see what bcom is, a capability specific to this object instance, which allows it to change its behavior. Change its behavior sounds interesting because it's not changing its state necessarily. It says it's changing its behavior. Dave says bcom is a capability to change the actor's behavior, and we're doing this so by calling the actor's constructor with a new... Okay, got you. Got it. Thank you. We're calling the actor's constructor with a new value and passing along the bcom capability to be used again. All right. So you're almost replacing the actor with a new instance of itself. The only state an actor has is its behavior, which in this case is returning a new case lambda, which really means you're just returning a new function. So the behavior is really just the function that responds to the value. Same actor, new behavior. So I guess there's an instance of the actor, but the lambda that's bound to that actor is the behavior. All right? All right. Yes, functions all the way down, or at least functions and maybe some state involved. All right, so you can see bcom is capability specific to this object instance. Bcom also has an optional second argument, which is used when we wish to return a value. Let's take that cell actor from before. If we want to return the new value after setting it, we can do that by specifying, the optional second argument to bcom. Do the same invocation as before. This time when we put a value in the cell, we also see it returned. So the setter version of it also returns the new value. That's kind of interesting. Methods aren't essential, but they are useful. Let's check that out. So the most common way to select different sub-behaviors isn't by the number of arguments. It's much more common to have methods that are selected by name. You can use the methods macro to do just that. So there's methods here. There's a macro that allows you to define methods for your actor. And it's basically dispatching based on a symbol like get or set. And you can have multiple parameters that are being expected by each of those methods, right? All looks like pretty much basically the same stuff here. The use of mCell is similar, but now you pass a first argument as a symbol, selecting the method, and the rest of the arguments are passed to the object. So now when we invoke things on this, we say jar get, jar set. jar get. So instead of it just being a plain old lambda, now it's a lambda that takes a symbol representing the method name as the first parameter, and then whatever comes after that are the parameters to that method. Methods aren't particularly magical. The methods macro just returns a procedure, which is convenient to use for procedure dispatch. So yeah, you can just kind of play around with methods yourself by using the methods macro, do the same thing, and then you can call it directly, and then the same behavior effectively is observed. So it makes a particularly useful kind of behavior procedure for you, one which takes a first argument for the method name, grabs the rest of the arguments, and applies them to the relevant method. Okay, cool. Fine. Objects which contain objects. Objects can also contain and define other object references, including in their outer construction procedure. Here's the definition of a counting greeter. So the greeter itself has its own state that's being defined. And this is really just working because of the way that procedures work in Scheme. Because Scheme is a lexically scoped language, when you define a procedure, you're defining an environment in which bindings can be created. And then whenever that procedure you create gets passed around somewhere else, those bindings are still in effect whenever you call into that procedure. So let me step back. When you have a procedure like cgreeter in this case, we're defining a procedure called cgreeter. We define a binding inside of that, either using define itself or using a let expression. And then methods here is actually defining and returning a new lambda or a new procedure in the context of this environment of the cgreeter procedure, meaning that times called now is state that is kind of carried along with the methods here that are being passed. So anytime that the cgreeter actor is invoked, it's increasing the number of times being called. So define times called spawn mcell 0. I think mcell is what we had from before. It stores a value. So that cell is basically a way to store a value, right? And I think the example here is that it's not just a plain old number that we're storing. We're actually creating an instance of an actor that stores a value to store that value, and we're holding on to a reference of it, and then we're returning a new procedure for this new actor called cgreeter, which then can call into mcell using the synchronous call. So times called is now a handle to this instance of mcell, and then inside of the methods for cgreeter, we're synchronously calling times called to get the number of times called, and also to set the number of times called by first getting the value and then setting it. So we're sort of doing all this stuff in the model of Goblins rather than doing it in the sort of quote unquote simpler way that you would do with just plain old Scheme code. All right. So we define a greeter called Julius. Julius get times called 0. Then we greet Gaius, we greet Brutus, yes, and then we call the method in the cgreeter get times called. It returns 2 because we're basically passing that call off to the mcell to get the value out of that. Okay, that makes sense. Asynchronous message passing. Okay, and the useful thing to note about what we just saw here is that methods aren't essential, but they are useful. You don't necessarily need to have methods. It's sort of like an optional thing you can do. This is all just functional programming using plain old procedures. So you can design your code however you want to, whatever makes sense for the purpose of the program you're writing. You can just use the same old tricks that you would use in Scheme to accomplish your goals. Asynchronous message passing. You've seen that the behavior of objects may be invoked synchronously with $. However, this only works if 2 objects are both defined on the same node and the same event loop within that node. And it definitely appears like if you try to call an actor that's not, or an actor instance that's not in the same vat that you're currently in, using the synchronous message passing $, it will give you an error. So you will know whenever you do something wrong with that, which is good. All right, let's see. Exit the AVAT subrep will make VVAT, enter that. So we define VVAT. You try to call Alice on B vat whenever Alice is defined in A vat. You do it synchronously, it gives you an error, okay? But you can do it asynchronously, send a message to Alice, and it will return a promise back. And this promise must be listened to. The procedure to listen to promises in Goblins is called on. So on is how you register a callback effectively for a promise that gets returned from an asynchronous message that you've sent. So we're sending an asynchronous message of Bob to the Alice greeter, and then we're waiting for its response by using on. That lambda that comes back passes the response, which is the greeting string that the Alice had generated. It says format T, heard back from Alice. Hello, Bob. My name is Alice. Okay. So basically, we get the ability to wait for Alice to return because we're sending a message from one vat to the other to invoke Alice's behavior. And the nice thing is that we don't really have to know how to address Alice in that other vat, aside from just having a handle to that that instance of Alice that we have obtained through the vat. It says, this is the lambda nature. Yes, it certainly is. All right, so not all communication goes as planned, especially in a distributed system. Consider an object which breaks in the middle of execution, such as in the instance of broken here. We signal an error using the error procedure, I guess. Is it a syntax or an error? Sorry, syntax or a procedure? I don't remember. On also supports the keyword arguments of catch and finally, okay, which both accept a procedure defining handling errors, defined to handle errors in the former case, and a code which will run regardless of successful resolution or failure in the latter case. So on has keyword parameters that you can use to provide additional lambdas for handling errors. And finally, that will get executed whether success or failure was the result. Okay, cool. Transactions make errors survivable. Mistakes happen, and when they do, damage should be minimal. With many moving parts, accomplishing this can be difficult. However, Goblins makes life easier. You can insert some debugging lines and print an error. All right, so borked C greeter. Define times called. The same thing as before. We spawn an instance of the mcell actor to store the count. Then we have our method definitions. If in the greet method, let's see. We throw an error after setting the times called, but before returning the result value. Okay. So we spawn it and then we run it, and then an error gets called. You can see from the PK debugging that times called cell should be incremented to 1, and yet when you call get times called, it's back to 0. So apparently, whenever this lambda for the actor is executing, if an error happens anywhere inside of that, anything that has happened to change the state of any other actor or any other object within the same vat that was executed synchronously will get rolled back to its previous state. And I think that's what it means by transactionality, is that whenever you are executing behavior synchronously inside of a vat, or even asynchronously, because I think borked C greeter would be called asynchronously from the outside. When you do that synchronous call to mcell, its state also gets rolled back. So obviously the state of the overall borked C greeter doesn't change because we never return from this procedure. So it never has a chance to become something else. But the state of mcell has already been changed because we called the set method on times called synchronously before we ever got to where the error executed. So because of that, the mechanism for executing the lambda for this object when receiving this message knows to roll back the changes to any sort of other objects that have been changed synchronously in the course of executing this particular lambda. Does that make sense? Niklaus asks, is state stored in the actor using closures? or is that in advised? And Dave responds, yes, it's stored using closures. But I think that you don't get the same transactionality though. Like if you were to have times call just be a normal binding here and you incremented that value without using an actor to store the value, then you do not get transactionality because you've already set a value in the closure that was created by creating the instance or basically calling this constructor function for the actor. So if you change that binding, if it's not itself an instance of an actor, then whenever this error happens, that value does not get rolled back. Because how could it? Because you're changing an environment binding inside of the original environment. So that's something to keep in mind. And I think that's the reason why this is actually using a... Looks like Ashraz has left the chat. This is why a cell is being used here instead of a normal binding. I'm pretty sure. This is what we're being taught something here. All right. So we've invoked it. We can see the error. We see that the times called is back to 0. See you, Ashraz. No worries, man. What time is it? Okay. Okay. So promise pipelining. Is this useful? I mean, we were supposed to be coding a little bit, but we're really just sort of learning how Goblins works, which I think is fine. Okay, promise pipelining provides 2 different features at once. Convenient developer interface for describing a series of asynchronous actions, and a network abstraction that eliminates many round trips. I guess because you don't have to wait for something to come back before you request for the next thing to happen. You can sort of just queue up a bunch of actions that can all be executed remotely, and then the final result comes back to you. Makes sense. All right. Consider the following car factory, which makes cars carrying the company name of the factory. So we have an outer function being defined, which is car factory, which takes the company name as the sort of constructor parameter. The constructor for cars, which we will create, which has internally another actor, it seems, being defined inside. So it has its own methods, method set methods, one being drive, the only one being drive. And then the outer car factory has its own methods. One is make car, which spawns a car. Okay, so let me just take a look at here. So with car factory, somebody would hold on to the car factory and they would call the make car method on that to say, I want a specific model of car and with specific color for that car. And what that does is it spawns a new car in the same vat with the model and color and then returns that. And then probably what we're going to do is then try to send a message to drive that car. So we want it to be driven, but it needs to happen after the car is finished being produced. So we enter the vat, we spawn the car factory called Fork Motors. That's pretty funny. And then we're going to send a message to Fork Motors to make the car. So we send the message to Fork Motors to make car, Explorist, and the color blue. And then that returns back a promise, which is this car val. So the promise for the asynchronous message gets stored in the binding called car val. Now you have a promise to a future car reference, but not the reference itself. You would like to drive the car as soon as it rolls off the lot, which of course involves sending a message to the car. Without promise pipelining, making use of the tools already shown, you would end up with something like this. On car val, then you would have a function that gets the car and then sends a message to our car to drive it. So the example being made here is that we're waiting for the car to come back, and then we're going to send another message to the car to drive it. And this is not the way that you would want to do things. With promise pipelining, you can simply message the promise of the car directly. So it seems what we're doing is we're storing the result of calling make car on the Fork Motors object, storing it in the car val, and then we're sending to car val itself the message for a drive. So what we're saying is for this future car that we expect to come back, send a message to it. So we're sending a message to the future car saying to drive, and we're waiting for that message to complete. It's interesting to think about how that works on the receiving VAT side. So you send a message asynchronously to the factory to create a car, and you get a promise back. Then you send another message on the promise, which must be looking at the promise on the Goblins machinery must be looking at any messages coming into the promise before it considers it fully complete, so that it can continue operating on whatever messages have come in, specifically with respect to the actor that might be returned by that promise, which is kind of interesting. All right. While clearly a considerable programming convenience, the other advantage of promise pipelining is a reduction of round trips, whether between event loop VATs or across nodes on the network. This can be understood by looking at the comments to the right of the two above code interactions. The message flow in this first case looks like B to A to B to A to B, because we're basically saying B is calling the car factory in VAT A to get a car, and it returns a response back to B with the car. Then B is now sending a message back to A VAT to tell the car to drive, which is then returning a response back to B. But now, with the pipelining approach, you only send messages to A, and then once everything is done, then it responds back to B. Okay, that makes sense. Now, how would I use that in a game? Perhaps you need to initialize a game object, and then you want to kind of queue up some actions for it to do before it's fully initialized, or before it even finishes the first action. So like you initialize a game object, you tell it to wander around for 10 seconds, and then after it finishes the wandering, you want it to drop something on the ground, let's say. And you can queue up those actions and just let it go without having to wait for those things to complete, and then continue your orchestration of the actions. You can sort of orchestrate everything up front and just let it go, and then do whatever it needs to do without too much trouble. Kind of interesting. All right, so is that it for the tutorial? What else we got? All right, the API. Okay, so that seems basically it. High level look at this. We have an objects API for constructing objects. We have the Vats API. We have the actor maps API, which I'm kind of curious about that really quickly. Transactional data structure underlying Vats. They are useful for building a custom event loop, such as for a video game, or as a synchronous one turn at a time mapping of actor references to their current behaviors. So let's take a look at the overview of that. I'm kind of curious. It's fundamentally a place in memory holding references to objects so they can be manipulated. There's two types of actor maps. Wactor maps, which use weak key hash tables as a backing structure. And then transactor maps, which are backed by standard hash tables and constitute every other generation of transaction history. Every other generation. Aside from their backing data structures and resulting use cases, all actor maps are very similar. Transactor maps simply also hold a reference to a parent, which is either another transactor map or the root Wactor map. Okay. Dave says actor maps are low level and you don't typically need to use them when writing Goblins programs. Vats use them. Yeah, definitely. I didn't think that it would be needed. I'm just kind of curious about what they are. Make an actor map. You spawn a cell inside the actor map. You can be invoked by using actor map poke. So this is kind of like the core mechanism for interacting with objects, it seems. Poke, AM lunchbox, peanut butter and jelly, and then we peek the value out of it. All right. Infreak says, so once you create the VATs, you don't really need them anymore. I think the way to say that is you don't need to hold on to a reference of the VAT because it's running. It's an event loop that's running. As long as there's stuff happening in that VAT, the vat will continue operating. The place where you would need a vat, I guess, is to spawn an instance of an actor within the context of a specific vat. To establish a program, to initialize a program, but after that, you don't really need a handle to the vat necessarily, do you? I mean, maybe you'll hold on to the vat reference in the top level of the program or something, or at least wherever the program gets initialized. It might be needed for some things. All right. You want a handle to it so you can control it. Okay, makes sense. I guess to stop it at some point. Let's go back and look at objects real quick. Got about 15 minutes left. All right, object construction. Let's see, spawn is a procedure that will spawn an actor using its constructor procedure and arguments. Procedure which returns a procedure representing the object's initial behavior, implicitly passes a first argument, bcom, which can be used to change the object's behavior. So it's basically a procedure that the actor uses to tell the mechanism above to change its behavior or state, effectively. Args, remaining arguments passed to constructor. All right, so spawn cell 42. Bcom argument warrants further explanation. It's a capability which allows the actor to change his own behavior. It must be called in a tail position. Okay, makes sense. Since bcom returns a data structure demonstrating that this object is choosing to change its value. Antler says, got a duck, but I love that you're streaming this versus other content. Always tune in for Goblins Code Me style when the schedules line up. Yeah. It seems pretty cool. Must be called in a tail position since bcom returns a data structure demonstrating that this object is choosing to change its value. It can also take a second argument which will be returned from the object's invocation as return value. A consumable object that returns a string explaining its current status. So we're defining an object or a constructor for an object called drink. Takes bcom drink name portions. Drinkable BEH portions. Be is a common suffix for behavior. Okay, so drinkable BEH, empty BEH. Okay, that's cool. It's a good example here. So what we are seeing is a constructor function that has two procedures inside of it that are being defined. And because these are being defined using define and not a let, they're both being defined sort of at the top level of this environment, so they're visible to each other. So that's needed because drinkable be at some point needs to use empty be to change its state. Starts off as drinkable be for portions. Drinkable be is a procedure that takes portions as a parameter and returns a lambda, which counts the number of portions left, which is not using a cell here, which is kind of interesting. It subtracts, so it starts off with the number of portions minus 1. It checks to see if the portions left is 0, and it will call bcom to change its state to now the empty BEH or empty behavior procedure. Meaning that now this procedure is going to be what is represented by this overall object. So you're just swapping out the lambda that will be called the next time a message is sent to this object. So that's how you can kind of swap out the actual behavior, is to actually change the state of an object. There's almost like a, what's the right way to say that? It's a state machine, but each actual state of the state machine is a procedure. So you can have multiple states of the state machine, like, you know, initializing, running, shutting down, dead, whatever. Those would all be distinct procedures, which when invoked have a different behavior. And that object itself still has its own independent identity, but the code that executes whenever it gets sent a message is different every time based on which behavior is currently the current one. And we change that behavior using the bcom procedure, which is being passed in as a parameter to the constructor of the object, right? I think I'm getting this now. It makes more sense. So when we call the constructor of drink, we're getting back a drinkable BEH, which returns that lambda, which controls that current state of the current behavior of the drink. And then eventually it will replace itself with empty BEH, which will now be getting executed whenever messages are sent to that object. Dave says, I don't like the BEH suffix personally. Bleh. Bleh. I don't like it. All right, so this is how it works at the REPL. Cool. Yeah, that makes sense. Synchronous calls. We saw that already. $, promises, making promises, spawn, promise, and resolver. You can create promises. They're conceptually similar to JavaScript promises. Yep. Let's see. Oh, wait. Most important difference is that Goblins promises support sending messages to the objects to which they will resolve, called promise pipelining. Okay, we saw that. Best way to understand promises is to use them. So in this case, keep track of the customer count in a cell. So we have a store. We define 100th promise and the 100th resolver, spawn, promise, and resolver. That's interesting. Oh, right. The spawn, promise, and resolver returns two values, and they get bound to 100th promise and 100th resolver. So this is like in JavaScript. When you create a new promise, there's a way to get to the result callback and the error callback. Or actually, there's a way to get the procedure to call to resolve the promise, right? Okay. I'm getting there. I think when you call new promise, you give it a procedure or a function that takes in two parameters. One is the resolver, and the other is the error function, if I'm remembering correctly. Anyway, point being, we're doing the same thing here. We're creating a promise, and we're splitting it in two: the promise itself and the resolver procedure. So we have a cell. Oh, define cell. Okay, I haven't seen that yet, but apparently there's a way to define a cell as a kind of a first-class concept. Good. We define a cell with customer count. We define our methods for listen. We hand out the promise for the 100th customer. Dave says there's separate capabilities. You can give someone the promise without giving them the capability to resolve it. Yeah, makes sense. Makes sense. Yep. So listen returns the 100th promise, which you're listening for the 100th customer, okay? Shop, when a customer shops, increment the customer counter. So new count is, we're getting the value of customer count synchronously. We're adding 1 to it. We're storing the new count. We're storing that new count back into customer count. Then when customer count is 100, we make a synchronous call to 100th resolver to send a message called fulfill. And we say, woohoo, 100th customer. So now if we spawn a store, we send a synchronous message to the store to listen. Then we give it a lambda to display the message that's being sent back whenever the 100th customer is now seen. Here, we do another call to the vat for a list of 100 values. The IOTA basically just generates a list of 100 items. For each of those, we're calling this lambda, which then synchronously invokes the shop method. And then whenever that 100th invocation happens, it will cause this lambda to be triggered because it is listening on the promise that is returned by the listen method. So the listen method is just returning a promise, and then this on is waiting on that promise to invoke a lambda with a message that comes back. Niklaus says, please do lots more of these Goblins exploratory videos. It's important and slightly inscrutable, so going through it like this is solid gold. Yeah, it's actually, I'm learning a lot too, so that's good. Dave says, would be nice, though I'm a bit biased. Well, yeah, that makes sense that you'd be biased because you work on this every day. Okay. Asynchronous calls. So we're sending a message to an object, and then we're getting a promise back with these. Now, hold on. So there's a variant that does not return a promise. Is that kind of like a fire and forget type of deal? And then there is an NP extern, like NP, but only operate on bar objects. This procedure can be used outside of a vat. Only operate on bar objects. So it won't let you, probably won't let you send a message to a near object inside the same vat. Why would that be necessary? Just to ensure you don't make mistakes? I don't know. All right. Let's see. Goblins provides two primary tools for resolving and operating on promise values: on and listen to. Neither of these pause program execution. So code following their invocation is conceptually concurrent with their various handlers. So what we had seen before with this with that right here is that we're calling on twice. So long as the vat execution of vat B is not, of vat A, where these two objects are being executed, so long as it's not being blocked based on what's being done in the lambda of the object's behavior, so long as that lambda is not being blocked, these two things will actually happen concurrently. So this on will register a lambda that will be executed when this promise completes, but then this on will just be finished. It will continue on with the next expression, even if this promise has not been resolved yet. So you can have 50 ons, so long as none of them are being actually blocked. You're basically just creating a bunch of callbacks for messages that are being sent. So you can just fire off a bunch of messages, and then whenever those messages have been processed and they return a value, then the associated code will be executed. So that's sort of the thing being explained here with on. On the completion of a vow, something will happen, right? The fulfilled handler is a lambda that is going to be called whenever the value comes back. And then the catch finally, and then promise question mark, which we need to understand. As mentioned above, if promise question mark is T, then on itself will return a promise. This promise is resolved as follows. If a vow is fulfilled and fulfilled handler is not provided, promise will return will share vow's resolution. If vow is fulfilled and fulfilled handler is not provided, which means you've called on and you did not provide a handler, but you said it's a promise, then the promise returned will share vow's resolution. So basically, the promise that is being returned by vow itself, or vow's promise, will be the promise that is being created by on will be resolved whenever vow's promise is resolved. Okay? If vow is fulfilled and fulfilled handler is provided, the resolution will be whatever is returned from fulfilled handler, unless fulfilled handler raises an error, in which case the promise will be broken and it's with its error value set to the exception. If vow is fulfilled and fulfilled handler is provided, the resolution will be whatever was returned from fulfilled handler. So it creates a promise that is going to be resolved whenever a fulfilled handler completes. If vow is broken and catch is not provided, the promise return will share vow's broken result. If vow is broken and catch is provided, the resolution will be whatever is returned from catch. Okay, so basically, if you don't provide catch, then the error will just be passed through whatever happens in the promise that on is waiting on. But if it has its own catch provided, then that catch procedure will be executed, and then its value will be returned by on. Listen to is wait for a promise resolved and then call listener with its value. It seems simpler. A more primitive interface to listen for promise resolution, mostly useful if you don't need to know the value a resolved promise returns, and you just want to know that it has resolved. Okay, so basically you're just waiting to see when it finishes, and then you just continue moving forward. Makes sense. Object reference predicates. We've got like 2 more minutes here, so I'm just going to try to get through this as fast as possible. Okay, so basically they're just predicates for checking objects. That makes sense. Okay, define actor. We saw this before. What is it for? Defines a goblin's object with an object name. Argument syntax is that a define or define star or lambda star, which allows you to provide keyword-based arguments or optional arguments. Does not support rest or allow other keys. That's fine. When restore is given with a procedure, that procedure is called to restore the actor upon rehydration. So that's where serialization comes in of actor state. We didn't really get to that, but the idea is that you should be able to persist the state of an actor to disk so that it can be loaded back up again, which would be pretty useful for a game, I think, if you want to save the state of the server before you shut it down and then pull it back up. Then it should be possible. We didn't get a chance to look at that, though, but maybe that would be something we would take a look at through the course of writing a game with this. Dave says, the stream has taught me that the Goblins manual is pretty good. I filed an issue about the sleeper demo. Yeah, no, it was good. When I actually sat down and tried to read it through and follow the examples and understand what it's telling me, it was immediate understanding. Like, I don't feel like I ever had to scratch my head and not really know what I'm looking at. So kudos to the Spritely team. All right, we'll look at this some other time. Define actor seems to be a way to do a bit more complex actor definitions. We will want to take a look at that for sure. And I like the sort of syntax I'm seeing here with methods using square brackets to kind of clarify the boundaries of a method. So anyway, we'll look at that another time. What else do we have here? Objects. Vats, anything special here? Vats overview. We kind of understand what a vat is now. There's a way to halt a vat or check if a vat is running. That's good. Oslo is pointing out a comment that I missed in YouTube. Is Guile an actual programming language or something like Bash? Is it distributed? Are distributed systems doable in this? Yes, it's a full real programming language. It's great. Creating vats. Looks like you can do some custom vats. Blah, blah, blah. Fine. Anything else? The other thing that was interesting was... Where was it? Let's go up and up. And up. Because I want to look at the actor lib. So there's a few things in here, which I think we're going to want to know. There's also stuff about like persistence, debugging, OCAP in. Like these are things that people should look at if you want to learn Goblins more deeply. But what's Fade blinking about? Are you blinking at the suggestion that Guile is an actual programming language? Or are you suggesting... Are you blinking at the fact that someone's asking if Scheme is real? Scheme is real. I use it all the time. Watch the streams on this channel. Cell. We saw that. We kind of need that to store a value, right? Provides a handy actor called a cell. They're used to store arbitrary data, but they're transactional. So you kind of need that if you want transactions to work on synchronous messages that are being executed on objects. You can make them read-only, write-only. That actually seems pretty useful. If Lisp isn't real. It reminds me of that recent meme with the lady on the flight, and she's getting kicked off the plane, and she's like, "That isn't real." You probably know what I'm talking about. I don't want to say the words. I would love to say the words, but let's just keep it clean. All right. Yeah. So you could return a read-only version of a cell that someone can't change. I think that's sort of the basis of the sort of the capability system. You have an object, but then you can return a version of it that they have less capabilities to use. You can only read, you can't write. So that's a way to prevent them from actually doing things you don't want them to. What is common? Actors wrapping functional data structures, allowing Goblins transactionality to guarantees while providing an apparently mutable interface. Spawn set EQ. A set as list. Oh, okay. So you're it's like collections almost. There's okay, set EQ is a set. Representing a set using EQ as the comparator, I'm guessing. All right, and then a hash representing a hash table using EQ for key lookup and equal for other comparisons. So there you go. That makes sense. So basic data structures, okay? Dave says, yes, that's a big deal. It's called capability attenuation. All right. I should stop the stream, but let me just keep looking. Facet provides an actor to wrap another object and only allow certain methods through. Okay, so you're sort of restricting access to methods. Provides a convenience function for constructing such actors. So you basically tell it which methods you want it to expose. All right, that's interesting. Inbox. An inbox actor that serves as a message queue. Messages can be written to and read from the inbox. That's also kind of cool. And if you think about it, all of this stuff is being written in a way that if you're in the same vat and you're making synchronous calls to these things, then all of this is transactional. So anything you're doing in the context of executing a behavior for a given object, if it fails before it finishes its execution, all that stuff will be rolled back, like all the way down the tree of changes that have happened, I believe. So it's kind of interesting. I needed to sort of think a little bit more about what the implication of that is, though, for a game. IO, we saw joiners combining the results of many promises. So basically, yes, if you have many promises and you want to wait on all of them to complete and do something with the result, that's something you can do. Let on provides convenient syntax to facilitate promise pipelining. Oh, that's cool. That's really interesting. So let on for 8 is equivalent to on all of doubler2, doubler4, match lambda 4, 8. I like that. So, okay, there's core primitives of which we looked at the whole stream in Goblins, and then there's this whole actor lib that builds on top of it and makes it a lot nicer. So the funny thing is that they didn't show us all the nice stuff in the documentation. They showed you all the low-level stuff to explain the model of things, and now you get to see all the fun stuff that you get to use when you write the stuff for real, but you just don't know that it exists. Methods we did see. Extend methods, expand a collection of methods, basically to add more methods, I guess. That's cool. That's great. I can see how these things would be really useful for game objects, like the behaviors that an object in the game can do. You can inherit behaviors from other sort of base types in a way. You could probably also combine, like mix-ins, I would guess. Yeah, because it's not a strict hierarchical thing. It's more of like you're just pulling in methods from other places, I'm guessing. Nonce registry, store and retrieve references using Swiss nums. All right. So like Swiss bank accounts. Give me 1 second. All right. Anywho. Anything else super useful? Pub sub. That might be useful. Publish messages to a set of other subscribed actors. Probably useful. Push down queue. FIFO queue, that's useful. Sealers. Ensuring the authenticity of data. Place data within a wrapper. Simple mint. Mint and currency. Ooh. We're getting into some crypto here. Swappable. mechanism to create an actor of one type and change it to another type later. Spawn and return values representing an actor and an actor which is a capability to swap that actor with another. Huh, okay, that's kind of interesting. Interesting. Timers, what is ward? Restrict access to its behaviors using the conceptual metaphor of a magical ward. Enchant. I like that. All right, there's a lot of stuff we'll have to look at later. Because, yeah, I don't have time to actually look into all of it. So, anyway, let me shut this thing down. I think Goblins is pretty cool. I think we came to a pretty decent understanding of how it works and how you would use it through the course of this stream. I think I will try to use it in the game that I work on for the Game Jam, just because I want to understand it a bit better and see how it might be applicable to some of the things I want to do for my own projects going forward. So hopefully it was useful for you too. Leave a comment on the video if you feel like you learned something from it, or just go to the forum. If you go to forum.systemcrafters.net, Ashraz has helpfully created a thread to discuss this stream. It's the first one up there, experimenting with Spritely Goblins. You can leave a comment there, or you can also go to the forum on the Spritely Institute website, so community.spritely.institute. If you have further questions about Goblins or Hoot or anything like that, you can join their forum and ask questions there, because we're not Spritely experts at the System Crafters forums, but they are over at the Spritely forum. So go there and ask them if you have deep questions. But otherwise, you should definitely let us know what kind of things you try to build with Goblins, because obviously it's pretty interesting. It's very functional. It's all functional programming principles baked down into this kind of interesting programming model. So if you are a scheme enthusiast or functional programming enthusiast, you should definitely take a look at Goblins and see how it leverages the distinct qualities of a language like Scheme to achieve some pretty interesting behavior. So I'm pretty interested in continuing to work with this, and you'll definitely see more from me on this next week. Dave also mentions come to our office hours next week. So the Spritely team also has an office hours where they have an open call where anybody can come and join. Is that on the website somewhere? First office hours, open office hours event. Yeah, I don't see where that's actually like is there like a main page people can go to? Anyway, if you are on, maybe they announced them on the forum. I don't know. Either way, keep an eye out for that. If you follow, all right, cool. Yeah, next office hours on 5/7. So there is a post here. So they seem to be making posts on their forum. Go subscribe to their forum if you want to be updated on when they have their next office hours. But that's basically an event where you can go just ask questions about anything you like regarding the Spritely projects. All right, I got to go. Thank you all for being here, especially super thanks to Dave Thompson for being here to answer questions, because that did help a lot as we were going through this. So thank you all, as always, for your time and attention. Hope you all have a great weekend. Until next time, happy hacking. See ya.